A disproportionation reaction is where an element in one oxidation state simultaneously undergoes both oxidation and reduction. So the element has to have at least 3 oxidation states, and it has to be in an intermediate state for this to happen. So a solution of copper 1 chloride sits in a beaker for an extended period of time. That's our example we're going to start with. So what's the reduction half reaction? The copper 1 is going to gain an electron to go to copper solid. So what's the oxidation half reaction? The copper is also going to lose an electron to go to the +2 oxidation state. So how do we get a balanced net ionic equation here? We're going to cancel out our electrons. So we have 2 of our copper 1 ions go into our copper solid and our copper +2. So our copper 1 is both oxidized and reduced, as it's in an intermediate oxidation state here. Now, like elements that exist together in 2 oxidation states can undergo a redox reaction to produce a species in an intermediate oxidation state. So the element has to have at least 3 oxidation states, and there has to be an intermediate state that falls between the states of the reactants. So solid iron filings are added to a 0.5 molar solution of iron 3 chloride. So let's start with our reduction half reaction. So the iron 3 is going to lose an electron to go to iron 2. The oxidation half reaction, our solid iron is going to lose 2 electrons to go to iron +2. So then what do we need to do to get the electrons to cancel? We've got to multiply the reduction half reaction by 2, and then we can cancel our electrons out. So our solid iron plus 2 moles of iron 3 will give us 3 moles of iron 2 here. In a combustion reaction where we have organic compounds, remember that combustion takes place in the presence of oxygen gas. We always get CO2 and H2O. These are very important types of redox reactions. They're important for energy production. Combustion of hydrocarbons provides fuel for transportation. It also metabolizes sugars, fats, and proteins in your diet. The products created during these combustions, remember, are always CO2 and H2O. And here you can see what the charges are. Your oxygen is always going to be 0. In carbon dioxide, you have a +4 for the carbon, -2 for oxygen. Hydrogen is going to be a +1, oxygen is going to be a -2. Now, in your hydrocarbon, that's going to depend on the composition of your hydrocarbon. Other combustion reactions, we've got the combustion of elements, and this can hold true for both metals or nonmetals. When we burn sulfur in air, we're going to get sulfur dioxide or even sulfur trioxide. There's usually a little bit of leeway in the answers for some of these reactions. Calcium, when we burn it in air, we get calcium oxide. Other redox reactions, when you have oxidation numbers assigned to elements in 2 compounds and they're at opposite extremes, then you may have a redox reaction to produce more common oxidation states. For example, hot iron 3 oxide added to a vessel containing carbon monoxide gas, you would have your iron 3 oxide, your iron would have a +3 charge. And then you have your carbon monoxide where the carbon has a +2 charge. Now in both of these compounds, oxygen is going to be -2. So what are our products going to be? We're going to get carbon dioxide and iron here. And the carbon prefers to have an oxidation state of +4, so it's going to be oxidized. Iron's oxidation number is reduced from +3 to 0 here. Now you could also get CO2 and iron 2 oxide. Iron is still going to be reduced from +3 to +2 when it forms FeO. And then of course we do have to balance this, and it looks like that. The oxidation of sulfite happens when the oxidation number of sulfur increases from +4 to +6. This is another special type of oxidation. Hydrogen peroxide, your oxidation for oxygen increases from -1 to 0 here. Now, in substances with lower or less positive oxidation states than usual, C2O4, this is your oxalate ion. So its carbon is going to have an oxidation state of +3. Because it's in group 4A, it would rather have an oxidation state of +4. So it's going to oxidize or lose electrons to raise that oxidation state from +3 to +4. When here we go. Some nonmetals can raise their oxidation states by bonding with like elements. This is going to happen when hydrochloric acid combines with a species that's easily reduced. When you have your chlorine ion or chloride, it's going to go to chlorine gas. So the oxidation number is going to go from 1 to 0. This is why we use sulfuric acid and not hydrochloric acid to acidify solutions when we perform redox titrations. And this is a special type of titration that we will look at. So what if you have a choice of two species that can be oxidized? When compounds contain P block or D block metals and nonmetals when compounds contain P block or D block metals and nonmetals that have less positive than usual oxidation states, the metal will be oxidized. For example, 10 + 2 will be oxidized to 10 + 4.